our learning objective, starting with lesson 1.6 today, it says I can solve, over here, eyes over here, I can solve an equation with 2 or more variables. There's a name for these types of equations. They're called literal equations. So when we have a literal equation, they're talking about an equation that has 2 or more variables. So not just an x, or not just maybe an a, but maybe an x and an a, you know, just kind of like our area formula for a rectangle had 3 variables in it. Capital A area equals little l times little w, length times width. 3 variables in it. So those are called literal equations. Some of them are actually called formulas too. But here's what they want us to do. They want us not to solve and get a value. We have to solve it for the indicated variable. So when they say solve it for this variable, that means get it by itself. So let's fill that in here. It means when we are going to be solving for an indicated variable, it means getting the variable alone. Getting the variable alone. So when it says solving for a variable, solving for an indicated variable, that really means get that variable by itself. Get it alone. So when there is more than one variable in an equation, what was one thing I said we could call it? When there's more than one variable in an equation, I just talked about it when I was referring to the learning goal. Starts with an L. You already forgot. Literal, there you go, literal equation. Well, sometimes those are also, often those literal equations are a formula for something. So A equals LW, that's the formula for what? That's capital A equals little l times little w. What's that the formula for?
Area of
Area of a,
area of
what?
whatever shape.
What kind of shape?
Rectangle.
Or a rectangle, yeah. Area of a rectangle. A equals LW is a literal equation, also known as a formula in this case, because it helps us find the area for a rectangle. So sometimes when we have those literal equations, we can also say this is the formula for something, and we can rearrange it. That's really kind of what happens when we solve for an indicated variable. When we solve it for a different variable, then we're just rearranging it. So the first one we're going to practice here is D equals RT. Anybody know what that is? What is that, D equals RT? How many variables does it have, first of all? Class, how many variables in it? 3. Thank you, Andrew, for being my class. 3 variables in it. Remember I said you have to be tuned in, you have to be engaged. You're not going to get this stuff not engaged today. So D equals RT has 3 variables in it. Anybody happen to know? Apparently I think it's some sort of a formula. Anybody think they know what formula that is? It's known as the distance formula. So apparently we haven't worked with the distance formula in the past?
Okay, we'll be pretty soon.
In science?
Yeah.
Okay. Well, good. We're going to be doing the same thing in science. So that little d stands for distance equals, the little r stands for, anybody want to take a guess? What? You were close. Rate times, and when r is right next to t, there's an invisible multiplication there, RT, so what do you think the t stands for?
Travel.
Nope. Time. Yeah. But it kind of, distance formula does talk about travel, doesn't it? So to get the distance, they're saying, how far you go, take how fast you're going, the rate, and multiply it by how long it took you. So let's see if that works. Let's talk about, maybe something that is, Fergus Falls is about 120 miles from here. If, I'm kind of like, the roads are kind of questionable. We're getting our first snow, and I'm not sure if the roads are icy or not, and I don't want to drive. What is the speed limit on Interstate 94? 75. And I'm like, that's kind of fast. I'm not really sure if these roads can handle that, so I bring my speed down to 60 miles per hour. should it take me, do you think, to get to Fergus Falls if it's 120 miles away and I'm driving 60 miles per hour? 2 hours. Yeah. So if I take how fast I'm going, 60 miles per hour, and I multiply by how long it took me, 2 hours, it should tell me how far I went. So all of it, when we multiply how fast we're going times how long it takes us, that should tell us how far we go. Well, when in the form that it is right now, this form D equals RT, what's it solved for right now? Remember, solved form means the variable is by itself. Which variable is by itself right now? D. So right now, that equation, that formula is solved for D. Well, if they tell us to solve D equals RT for T, they're saying they want to get T alone. In other words, don't let D be the one alone anymore. Now I want T to be the one that's alone. So D equals RT, right now in that form, it is solved for D, but we have to solve it for T instead. We're going to use the same rules we've been doing as if this had numbers in it. So if let's use the Fergus, kind of like the Fergus Falls one over here. You don't have to put this in your notes because it probably won't make sense later when you look at it. If I know that I'm going 120 miles, and I know that I'm going to go a speed of 60 miles per hour, and I just don't know how long it's going to take me, what would I do to solve that equation? Because we know how to solve that. What would I do? I would divide both sides by 60, wouldn't I? I would say, oh, well, to get T alone, I'd have to divide both sides by 60, and then I would know how long it took me, right? Well, we don't have any numbers in our stuff. So we have to take it in the D equals RT form, and we have to get that T by itself. So T is being multiplied by R, right? T is being multiplied by R. So we just have the same thought process as we do up here when we said T was being multiplied by 60. What did we do? T was being multiplied by 60 up there, and what did we do? What did we do? We divided by 60. So over here, T is being multiplied by R, so what do we have to do with that R? Divide both sides by R. Yeah. So even though it's not a number, that's okay. We're still going to use the same thought process. T is being multiplied, so I want you to write D equals RT again. Write it down again. So this is how it started. This is us showing our work now. We're going to divide both sides by R because T, the variable we want by itself, is being multiplied by R. So we need to say, oh, well, these R's will cancel out. Can you really divide D by R and get something sensible? No. So here's what you do. You just leave it like that. Don't mess with it. And the R's canceled out. Is T by itself now? Yeah, that's what they wanted. They wanted us to rearrange the equation so that T was by itself rather than the D. So you're going to get answers today that are going to be like, how do I know this is the answer? I feel like I should do more, right? Something's wrong. And that's because we're not going to have all those numbers involved.
This is LeGrand.
Yes?
Is Preston Wynn in there?
No, he is not. He's in Mrs. Crevison's room. Thank you.
Thank you.
So here's what we're going to do. The reason that we rearranged it also is so that we can use it. So we're going to write it down here. And it says, if the distance driven was 270 miles, so we're going to substitute the distance in for D, and the average rate, R, was 60 miles per hour, how long did it take? We don't know. That's our T, isn't it? And now you may use your calculators. 270 divided by 60.
4.5.
4.5. So T equals 4.5. Now, here's the, kind of tricky part. We have to make sure we know which label to give it. Distance would, in this case, would be measured, distance is measured in what? In this problem?
Time.
No, distance is measured in what?
Miles.
Miles. The rate was measured in,
Time.
no,
No.
miles per hour. Miles per hour, so what's our time going to be measured in? Hours, yeah, it's 4.5 hours. We have to make sure we also know how to give the appropriate label when we have to use our equation to help us find something. Just like when you had to use your equation in your homework for today, when you were looking for one width, it was measured in feet. Okay, so here's us solved for t. I want you to put that in your notes, please. Solved for t. That's what they asked us to do. We'll put that in your notes. Circle what our final answer was. But you know what? We did what they said. We solved it for t. We got t alone. And then in part B, we were using our newly named equation. It's still the same equation, just a new name for it, rearranged. Using our new equation to help us solve for time. So, anyone have any questions on this side before we move on? Okay, then let's go to the back side. Number 2, V equals LWH. Does that look familiar to anybody?
Yeah.
What is that? Volume. And what is length times width times height, yeah. Volume equals, and like when we have volume, area, those kinds of things, typically we capitalize, so that's really like a capital V, so it doesn't look bigger, make it bigger. And you just told me that the L then is length, the width is W, and the height is H. So this is kind of sounding to me like it's the formula for something. It's the formula for finding the volume of what? What is this finding the volume of? What? A normal square. Well, if it's a normal square, squares are two-dimensional, and this is actually a three-dimensional figure. So it's kind of like a cube, but if it were a cube, then all the sides would be the same. So we don't know that they're all necessarily the same. So a cube is a special type of rectangular prism. So this is a volume, I want you to put this up here, volume of a rectangular, because sometimes our rectangles aren't squares, so we're not sure that this is a cube. Volume of a rectangular prism. That's what this is actually the formula for. If I asked you to find the volume of this room is actually a rectangular prism. We would take the length of the room times the width of the room times the height of the room, and we would know the volume of the classroom. Okay, so right now that volume formula is solved for what? What's it solved for right now? V equals LWH. What's it solved for in that form? Okay, well, that's what they want us to solve it for. What's it already solved for right now? It's already solved for something. It's solved for right now. Remember what solved for means? Whatever it is solved for is by itself. What is by itself right now? The V. So right now, this is solved for V, because V is by itself. Right here, it's by itself. So right now, it's solved for V. They want us to solve it for H. They want the H to be by itself. So get H alone is what they're asking us to do. So we're going to look at the side that H is on, the one that we want to be by itself. We're going to say, what's happening on that side with the H? So Holly, what's happening in this? What's happening to H in this formula? I'm waiting on Holly. No. Blake?
It's being multiplied.
It's being multiplied. It's being multiplied right now. There's not a fraction bar there. There's no division symbol there. It's not being divided by anything. H is being multiplied by both what? L and W. So since h is being multiplied by both of those, we're going to make this one easy step. We're not going to try and make it into 2 because that'll confuse us. We're going to divide. Division undoes multiplying. We're going to divide by what h is being multiplied by. It's being multiplied by L. It's also being multiplied by W. So we're going to say we can now divide by LW. Okay, so how are we going to show that? Well, we are going to take our equation with the, and we're going to show, I've rewritten it for us already. We're going to divide by LW. We're going to divide by LW, divide both sides by LW. Well, because it's multiplication, just like it was in our distance formula, since it's all multiplication, when you have multiplication, upstairs and downstairs are the same factors, you can cancel them. So these L's cancel, these W's cancel, only because there's multiplication. There's no addition going on here, no subtraction going on here. This is why we can cancel them. Now H is by itself over there. Well, how about V divided by LW? Is there anything we can cancel there? Anything alike upstairs and downstairs with multiplication? No. So we can't really do any dividing, so we just have to leave it V divided by LW. V over LW. The H is by itself, that was our goal, and we don't have anything we can do with that other side, so we're going to have to write it just as it is. So again, let's put here, solved for what? What's it solved for?
H.
H. Solved for H. That's what it's going to look like. Now, again, I'm cautioning you right now, I do not want to see on your papers tomorrow, I want to be able to look at your paper and be able to tell what did it start out as before you did anything to it. You do not start right there doing your work. You rewrite it again like we did, like I actually did for you, and then you start showing your work. So this one does not get touched. It gets rewritten again, and then you start with that work in that step. Anybody have any questions on that? Okay, well then it says if the volume of a rectangular prism is 180 cubic inches, and the base has a length of 5 inches, and a width of 4 inches, what is the height of that prism? So we're going to, first of all, we're going to just take our, can I turn it around like this, by the way? Can I do this? Can I take how we had, it ended up there and rewrite it like that? Yeah, sides of an equation can trade. So I can first write it like that and say, I'm going to use my new named formula because I'm looking for the height. Well, that's what H is. So since I'm looking for the height, I'm going to use this and I'm going to substitute in, what am I going to put in for capital B?
Mrs. LeGrand,
Yes.
can I get Holly Wiggins to the junior high office, please?
Yes, you can.
Thank you.
What's going in for B?
The 180.
The 180. What's going in for L? What's going in for L? 5, and we don't have to put the inches at this point, okay? And then it's LW, so that means multiplication. So 5 times, what's the width?
4.
4. Okay. Now we're going to do some simplifying before we actually divide. 180 is going to stay 180 for right now. 5 times 4 is what? 20. I don't think we need our calculators this time. I bet we can do this without them. What happens when you divide something that ends in a 0 by something else that ends in a 0? Those cancel out, don't they? What's 18 divided by 2? 9. So the height of this prism is 9. What do you suppose we would label this as?
Inches.
Would it be cubic inches? Would it be inches? Would it be square inches? What would it be? Okay. It's a height. It's like a length, you guys. inches squared would mean area. It meant you took some inches times some inches. No. We measure. If I measured the width of this room, and I probably have to, that doesn't even make sense, but and I got 5 inches, and I measured the width, and I got 4 inches. If I measure the height, it should also be inches. Because here's where cubic inches came from. Inches times inches times inches. 3 times you multiply inches, they become cubic. These lengths, heights, widths, they're always measured in a one-dimensional. Inches are one-dimensional. So this would be inches, not inches squared. When we took 5 times 4 here and got 20, that's actually inches squared. And the 180 is inches cubed. So when I take that and divide it out, there's only inches actually left. Okay? So anybody have any questions about anything on the back side of